Hello, so this is my CSCI 4253 final project. I call it automatic neural network training. So team member is just me, Kevin Bueller, and then a project overview. So I created a service to fully automate any general deep learning training job. So this works for any model, any data. So what the user can do is they can upload their model to our service. We're going to train it for them and then spit back out the trained model for them so that they can just like download it and use. So list components, I'm using 6 of these software components that we learned in our data center class. And then more specifically, I'm using a Flask REST API server, MinIO for blob storage, Docker, Kubernetes, Prometheus for containers, and I'm using a Pika Rabbit MQ queue, base 64 encoding and SHA-256 hashing, and then Redis key value store. So architectural diagram. So we can see here my API interface at the top has 3 routes. So we have a post to train, get status of the training job, and then get our model, which downloads, like sends the file of the model. So RabbitMQ, so this acts as a load balancer and is for workers to consume from. We also have a Redis key value store to store hash to loss pairs. So that hash is the model hash, which everything is like being tracked from. And we also have Kubernetes where implemented horizontal pod auto scaling, where we have like workers, 3 default workers that'll actually do one training step that they grab from the queue. And then yeah, Prometheus for monitoring CPU usage. So demo, we have MNIST MLP demo where we're going to train on all of MNIST and then see what the accuracy is. So let me spin this up real quick. So right now we're building the newest Docker container. We're creating our Rabbit MQ, our Redis, and IO, and then we're gonna have our Flask server running here as well. And let me talk about stuff while everything is loading. So at a high level, we go from Flask to MinIO to our MQ to our Kubernetes worker, and we can see here that our server is loaded. So I can run the demo right here. So we're gonna load MNIST, and then we're gonna upload our model, and then it's gonna start training. And every 5 seconds, we're gonna pull, okay, what is the newest batch loss from MNIST? So it's uploading right now. So our component interaction, so we have our training API, which you can upload a torch script model because you can't do torch.load unless you have the actual class definition. And since this is a service, we don't want to see the class definition. We just want to have the model. So we can do like model equals torch script.load. And then this returns a 256 hash, SHA-256 hash to track our training job. And we can get the model hash ID and the status. So our training jobs are hashed and then queued with RabbitMQ. 3 default workers can continually consume from the queue, and workers grab a torch script model and NumPy dataset using the hash from MinIO and then enter that training loop. And then we store this to the Redis server, and our model hash is sent back to the user. So we can see here that our batch loss is going down pretty smoothly. So this is really awesome. So that's running in the background, and I'll show you when it's done. So for testing and debugging, so kube control logs, worker. This is awesome to see like, okay, what's actually going on inside of our worker. And then like logger.info, setting that up. And then for testing, I implemented a horizontal pod autoscaler for repeated job requests. So we can see here from this Prometheus CPU usage, we're hovering around 8%. So I can set the autoscaler to, hey, if it goes over 10%, create a new worker, so that we can have like a bunch of workers. And realistically, we want this at like 70%. But I've also tested this on like an MNIST MLP. And we just like upload the model. There's no like model definition. This is like pretty general for all Torch MLPs. So a potential bottleneck is like memory limits inside our Kubernetes pod, and then reaching the MinIO default storage limits. So if you have a really large model, the horizontal scaling is not gonna be enough. You're actually gonna have to like, add a GPU, put this on a really nice server in the cloud. And then another bottleneck is kind of annoying. So torch.load doesn't work unless you have a class definition at runtime. for whatever reason. So the models must be loaded and saved in torch script. So you can just like download the model and do like model equals blah, 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 and then like train it from there. So here, okay, this is really good. So we saw that our batch loss like continually went down. So this just runs on 2 epochs. That's what our demo does. And then, so we download the model. So we send this file and it's actually downloaded onto my computer and we're doing some prediction with it. So our base model only has a 5% accuracy. And then after 2 epochs of a super simple multi-layer perceptron, we have a accuracy of like 67%. So yeah, that's my demo on my project. Thank you.